This video is a general walkthrough of feature definitions and SUDA models that are available through the KDOT workspace. To begin, it's important to understand at least three key terms when working with the ORD application for subsurface utilities. First being the feature definition itself. The feature definition defines what an item is. It can be comprised of a few things, including element templates, feature symbologies, annotation groups, SUDA cells, etc. There's also feature symbology, which defines how this item is displayed, and this will be different whether you're viewing the item in a plan view, a profile, or 3D view. And lastly, there are element templates and annotation groups, and these are graphical attributes that can be defined, and this is typically what we think of when we think of levels, colors, line styles, etc. For subsurface utilities, the feature definition library can be found in the workspace KDOT standard civil dgnlib feature definition folder under KDOT SU, meaning subsurface utilities, features, annotations, element, temp, dgn, lib. This is the dgn library that contains all the subsurface utility feature definitions, and it also acts as a hydraulic seed file for the project as well, which will come into play later. It's important to know that this references the 3D SUDA cells and plan view SUDA cells for the drainage utilities, but does not contain it within the library itself. It references them in its own cell library. To better illustrate the feature definitions found within the KDOT workspace defined, it's probably best just to view them within the library and how they come out. This is the KDOT subsurface dgn lib, and you can see the library contains the feature definitions, symbologies, etc. If we're looking at, for example, a catch basin, you can pull open the feature definition and open up, there's several options: nodes, conduits, and catchments or drainage areas. Would open up node, stormwater, catch basin, and of course there's different feature definitions as well, end sections, head walls, etc. For this example, I've opened this up in the ORD Explorer, and this is the element properties that we're displaying here. Under the feature definitions, you can see a name is defined, a description, a name seed. This is the prefix. When you place the item, it'll start as CB0, CB1, etc. There's a default height that can be changed. This obviously can be changed with a box if it needs to be deeper or the invert's adjusted. This is just what it puts when you place it originally. It's the default. Use slope of surface. The inlet grate itself, the top of the lid, can be sloped to match a gutter section or a channel, whatever the case may be, and it'll be associated with the terrain and use that to match that. The structure type is just dependent on what type of inlet we're looking at. In this particular analysis, the ditch inlet we've modeled as an inlet grate. There is different types of networks. We're only dealing with stormwater here. And there are prototypes. This hydraulic prototype is important because it defines how the hydraulics are calculated, rim elevation, HGL, all the attributes separate from the feature definition and its own hydraulic properties. That's what we're referring to here with the hydraulic prototype. It's the analysis itself. And then we look at symbology, and we have point feature symbology, connection region, and solid feature symbology. Connection region is simply just how a pipe connects to a node, and we're not going to go into that in detail. But the important stuff to know is the point feature symbology and the solid feature symbology. Essentially, this feature definition is pointing to a point feature symbology, which refers to the plan view, and a solid feature symbology which reviews to the 3D view. And these will point to the symbologies that will point to the SUDA cells themselves.